All right, let's work practice problem number 1 on page 251, unit 8. This is in chapter 11 of your textbook. And here's what we've got. This is from a previous example, these givens. We have a car, 875 kilogram car. It's moving at 44 meters per second. And there's a constant braking force. And so here the car is moving half the speed. And then here the car is stopped. So we're constant speed all the way, or constant deceleration, right? Constant force. We want to know how much work did that force do to slow the car from 44 to 22 meters per second? How much work did it do to slow from 22 meters per second to rest? And then what's the ratio of these distances here, like this delta x1 and this delta x2? We'll use energy methods to do that. So let's solve it. Okay, solve. So for part A, this is the net force on this car, this braking force. And so the work done by the net force is equal to the change in kinetic energy. So this is the work done right here. And so this is going to be K final minus K initial. And this is K final is, well, for the first part, this is the final velocity. So this is going to be 1/2 the mass times the velocity squared, final velocity squared, minus 1/2 the mass times the initial velocity squared. Oops, forgot the square there. Now, one thing I saw some of you doing as you were working on this is that you correctly distributed out the 1/2 and the mass just to make it a little bit easier. But you can't just go 22 minus 44 and then square it. You have to go 22 squared minus 44 squared. And can I borrow somebody's calculator, because somebody borrowed mine and I don't have it up here. Thank you very much. So, it's something I don't know how to use. All right, so I'm going to go ahead and factor these out. So 0.5 times 875. And you get 437.5 when you do that. Now multiply that times, and then I put in parentheses 22 squared minus 44 squared, close parentheses, and you get the work done for part A is negative, and it's negative a lot. 6.35 times 10 to the, let's see, 1, 2, 3, 4, 5 places, joules. And the negative is very important because this force is taking away kinetic energy. It's taking energy out of the system. It's doing negative work. Another way of looking at it is that this force is to the left, but the displacement is to the right. So when you have a force and a displacement that are in opposite directions, negative work is being done. Remember, it's force times displacement times the cosine of the angle between them. Cosine of the angle is 180 degrees. So the cosine of 180 degrees is -1. So everything tells you that that should be negative. Now for part B, we're going to do the same thing. It's the final kinetic energy. But here's your final position right here for part B. It's at rest, so it's going to be 0, minus the initial kinetic energy, which is just 1/2 875 kilograms. And then this is now your initial velocity if you're going from here to here. So that's going to be 22 meters per second quantity squared. So let's figure this out. 0.5 times 875 times 22 squared. And you get two, and it's negative. I want to because of this minus here. So the work is going to be negative 2.12 times 10 to the 5 joules. Now, and so that's my answer for part B. So here's the answer for part A, part B. Everybody agree with that? We did it? Looks like it. Kirk, you did it right. All right, and then part C. We want to know the ratio of the distances. Well, let's figure out the ratio of the work done. So here's delta x1. But what I'm going to do is I'm going to say, watch, this is the work done by 1. And I'm going to call this from here to here the first part of the problem, divided by from here to here the work done the second part of the problem. That's what the 1 and 2 refer to. Well, remember that work is equal to the force times the displacement times the cosine of the angle between the force and the displacement. Force times the displacement times the cosine of the angle. Now, the force is going to go away, and the cosine theta is 180 degrees, right? The force in the, so this goes away. And so this is the delta x for the first part of your problem. And this is delta x for the second part of your problem. So the ratio of the displacements is just going to be the ratio of the work. So that's kind of tricky. Well, the work done from the first part, we'll call this W1 and W2, is negative 6.35 times 10 to the 5 joules divided by the work 2 was negative 2.12 times 10 to the 5 joules. Now there's a little rounding off difference here, but if you multiply this by 3, you get that. So the answer is 3. Or, I mean, that's the ratio of delta x1 over delta x2. So it takes you 3 times, you go 3 times farther, breaking the first half, breaking half of your speed away, than you do this. So let's say it took you, 80 meters to stop. Let's go from here to here was 80 meters. Well, this would be 60 meters, and this would be 20 meters, right? 3 to 1. This distance is going to be 3 times greater than this distance. Which is, now what's the importance of this? And the idea here is that when you are going at high speed, it's going to take you a long time. I mean, not a long time. It's going to take you, you're going to go a long distance while you brake to half your speed. And then braking the other half of your speed, it's a much shorter distance. 1/3 the distance this is. Anyway, any questions on practice problem 1? All right, that is all.